Hello and welcome back. I realize it's been quite a while since I've made a video and feeling a bit out of practice. But it's Labor Day, May 27th, 2018. I've got a 3-day weekend and a little bit of time on my hands. And I wanted to see if I could get a video out. And this one's going to be kind of a follow-up or a response, or whatever you want to call it, to Paul Carlson's latest capacitor tester. He's made a nice solid-state unit that runs on, I believe it's 3 9-volt batteries, 27 volts, which makes it quite a bit safer to use than these two units. He also demonstrated that the sensitivity was better than his IT11, and that kind of surprised me because the IT11 as well as the IT28 have a DC amplifier in the leakage test circuit. However, it is shunted to ground here at 1.5 megohms, which is fairly significant. If you're trying to detect leakage in the gigohm region, you're pretty much shunting the leakage to ground. However, it is much better than the Heathkit C3, which is sitting here. The Heathkit C3, if I can come up with the right schematic here quickly, is shunted to ground by something on the order of 1/3 of that. There's a 470K and a 1000 ohms, so basically 480K to ground on the grid of the iTube. Is that clear? I should be looking in my viewfinder here to see if that's readable. There's 480K here to ground, shunted across the grid to the iTube, which, again, seriously reduces the sensitivity of the C3 to find leakage, because it's going to shunt the leakage to ground before it has a chance to have any effect on the iTube. My go-to unit is the C2. I prefer the C2, and I've been using that one as my go-to leakage tester. I have up here on the bench a Sencor unit, but I bought that mostly to make customers comfortable. They'd rather see something commercial than a Heathkit on the bench. However, I use the Heathkit because I like it, and it's quick and easy. The beauty of the C2 is it has nearly infinite impedance for testing for leakage, and that can be seen here. The capacitor under test is in series with a 200K resistor, which is in parallel with an NE51 and a 0.5 microfarad capacitor. And the way this unit works, if there's any leakage at all in the capacitor, it slowly charges this capacitor. Now, this is all predicated on this capacitor being a high quality, absolutely leakage free capacitor. Now, I'm using Sprague orange drops, which are, it's going to be tough to find a capacitor of better quality than a Sprague orange drop. And the tiniest amount of leakage will eventually charge this capacitor and cause this lamp to discharge. When it discharges, when the lamp turns on, it discharges the capacitor. Then the process starts over again. So you get a blink, blink, and the worse the leakage, the faster the blink rate. The way that works, oh, hang on just a second. Okay, the NE51 neon lamp has a breakdown voltage of about 90 volts DC. So you're still working with direct, with a fairly high voltage. Now, the Heathkit says this is a 20 volt range, and that's just a bald-faced lie. The unit would never detect leakage at 20 volts. The lamp would never turn on. It takes minimum 90 volts for the lamp to ionize and turn on and flash. So the actual output here is about 120 volts DC. It's seriously current limited. However, it's still high voltage. While the unit itself will give you a pretty good tingle, the real danger comes when you've got a capacitor under test and it's fully charged. The capacitor discharge carries some serious current behind it and can hurt you. Can hurt you pretty badly. You'll also notice a neon lamp has a volts AC breakdown of 65. That's because the peak RMS voltage of 65 volts is actually 92 volts. They run the lamp, they suggest 125 volts with a 220K series resistor, and that limits the current of the lamp to 800 microamperes. At 800 microamperes, it has a life of 25,000 hours. Now, it has a maximum current rating of 300 milliamperes, but if you run it at 300 milliamperes, it's only going to last a year or so before it turns black and fails. However, like an LED, these neon lamps, whether it's one of these NE51s or something of this ilk here, they have to have a series resistor. If you don't have the series resistor and you try to put 124 or 125 volts or even 90 volts across them directly, at worst they'll turn black and fail, or excuse me, at best they'll turn black and fail. At worst they'll explode, depending on how much current your source has. So you have to current limit them. That has two advantages. The bulb lives a long time, and you're less likely to get shocked when playing with the circuit I'm about to show you, or seriously shocked. Now, in response to Mr. Carlson's unit, which has a fair amount of complexity, means you're going to have to buy a circuit board and a bunch of parts. Now, remember, he does have the advantage, a serious advantage, of he's working with low voltage. Whenever I'm using these units, I'm working on an old tube type radio. Can have 3, 4, 500 volts of DC inside of it at a fair amount of current. So I'm used to working with high voltage. If you're not comfortable with high voltage, if you don't know your way around this equipment, I suggest you don't play with it. This stuff can hurt you, it can kill you. Okay, having said that, this is what I came up with that will greatly, immensely improve the sensitivity of your Heathkit condenser checker C3, and will even help marginally with the C2. The entire circuit inside of this box consists of these three components: a 0.02 microfarad capacitor, a 330K resistor, and an NE51 lamp. That's all that's inside of this box. Those are the only components you need. Now, I've built it into a little box, so it's got BNC connectors and it's a little more convenient to use. I don't have test leads laying all over the table. I got a bunch of these little boxes at one of the electronic surplus places. They were selling for $1 a piece. They had 3 BNC connectors. Some of them had 5 BNC connectors. They're antenna splitters, 3-way splitters, 5-way splitters, etc. At $1 a piece, you couldn't pass them up. Nice little aluminum box with BNC connectors on it. Here on the table in front of me, I don't know how clear you can see that, I have a bunch of resistors in series, and I just got tired of soldering resistors together, and it started taking up a lot of room. We have roughly 3.25 gigohms of resistance here. There's a bunch of 15 megohm resistors, there's some 20 megohm resistors, there's some 12 megohm resistors, all in series. I just grabbed all the resistors I could find, stuck them in series, so I had a very, very high resistance. That was to test the sensitivity of these two units. Now, if I plug this into the C3, I found out that it fails pretty dismally. It can't detect 3.25 gigohms of leakage. And if you've got a paper capacitor of this style or of any style paper capacitor with leakage in it, you want to know about it. And that's where Mr. Carlson's unit has what he calls prediction, I believe he called it, where, you know, capacitor might fail sometime in the future. Now I'm going to set this on test, and I'm going to turn the knob, and if you can see the eye in there, it blinks and goes back wide open. Now, the disadvantage to having this automatic discharge circuit, the eye blinks. Did it really go back to full open? The only way to test that is to hold it in that test position and remove the test lead and try. I'm hoping that's in frame. Is that in frame? Yes, it's in frame. Get back up on the table. So by holding this there, I'm seeing no deflection of the eye. Now I'm going to run this all the way up to 450 volts. Here's where things get a little dicey. I'm playing with high voltage. I am comfortable with this. I've been doing it for years. I warn you, this is somewhat dangerous. So I'm going to try this again. I'm going to hold this in the leakage setting, and I'm going to touch this on at 500 volts. And you may or may not see there's a tiny, tiny deflection in the eye tube. That is reflecting leakage at 500 volts. However, if I leave it on there and turn it, can you really tell that the eye, in fact, the eye goes wider, slightly wider when I put it in the test position, until I remove the clip and it goes wider still. So in the normal position, it is slightly closed. So you could be easily fooled into thinking a capacitor, if you replace this with a capacitor with leakage, you could easily be fooled into thinking there's no leakage there, unless you held this in the leakage position and put this test lead off and on, and then you can just see at 450 volts there's a slight closure of the eye. That tells you there's leakage in that capacitor. This one here, I don't even know if it'll register the leakage on this cap. This cap is rated at 400 volts DC. I'll take a chance at 450 and leave it there. Let's see if it can detect the leakage in this cap. Okay, first it charges and then it opens. I cannot see any difference. As far as I can tell with this unit, there's no leakage in that capacitor. Now I'm going to go over here to the C2 with the neon detector, and I'm going to plug it into this one, and I'm going to turn the voltage up to 400 volts. And we should see, over time, we should see a blink, because eventually the capacitor inside of there is going to charge to the point where that lamp discharges. Or it should, anyway. This unit uses the neon lamp. Remember the circuit I just showed you. What did I do with the clipboard? Oh, it's on the floor. And we'll grab that. And here we go. Has it blinked? I haven't been looking. Basically, the circuit that's in there is the 330K resistor. Actually, theirs is 200K. The device under test, and the combination of the NE51 and a capacitor. Now, eventually, that is going to blink. However, that uses a 0.5 microfarad. The reason they're using 0.5 microfarad is it's going to give you a brighter flash. The downside is it takes a long time for the voltage to build to a point where it's going to blink the light. So the flash rate's very slow. Let's see if we can hurry it along. No. I know this capacitor leaks, and I'm going to prove it here in just a second. I am going to put this in series with what's in the voltage that's coming out of there. And on my unit here, this is the schematic for this. It's showing the voltage source going in, which is this BNC connector here. A C2 capacitance tester, a C3 capacitance tester, the IT11, the IT28, an ICO, whatever you might have. They're going to have voltage present on the terminals for leakage, and you can use that voltage, or you could use something like this Heathkit high voltage supply that's sitting up there at the top. Now that's a lot more dangerous. That is not current limited, but you can use that voltage source along with this schematic if you don't have one of these capacitor testers, but you have a high voltage source, you can do that to test for leakage in these capacitors. So I am going to remove these two. And I do everything, or not everything, I do a lot of stuff using BNC connectors simply because it's easy to do. And remember, I should turn that down. There's 400 volts, 450 volts present there when I'm doing this. I'm going to plug this into the input. Ouch, the capacitor was charged. I just got bit. And what the heck did I do with the testers? Here they are. So I say, you're playing with high voltage here, and I'm distracted because I'm talking, but this just discharged. In fact, it just made another pop. So my touching it didn't discharge it completely. I am on this capacitor now. My device under test is in series with the Heathkit tester, and I'm going to turn this back up. And let's hope you can see this. I'm going to turn the camera down in this direction. Blink. Come on. Oh, we're on 300. Oh, there we go. 400 volts. Blink. 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 And it's slowly there, but just blinked again. That is showing that there's definitely leakage in this capacitor. And the reason this one's blinking and that one's taking so long, this only has a 0.02 microfarad capacitor on it. It's not nearly as bright as the blink that comes from that unit, but it's the flash rate will be much faster because I'm only using a 0.02 instead of a 0.5 microfarad. So for a handful of parts, you can very quickly test for leakage at extremely high leakage rates. Now remember I said this string of resistors was 3.25 gig ohms. If I connect this to one end of this string and to the other end of the string and go back and turn it on leakage, and I'm going to go to 150 volts there. Blink, 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 blink. You can see this lamp. That's 3.25 gig ohms of leakage. And if I turn this down, it still should work. There's a blink. There's a blink. That's only at 125 volts, which is a reasonably safe voltage for DC. And you can see that's blinking. Now if I take this out of the circuit and use just the test leads for the C2, I'm going to plug that in there and grab the other one over here, plug that in here, and I'm going to go across this same string of resistors that I just tested with my homemade unit, and we should see an occasional flash from the C2. And let's see how long. I'm going to ramp it up just to get the cap started in the C2. What am I not doing here? Why is this not working? Should detect it. There it is. Blink. Am I in frame? Yeah, I'm in frame. Looking in the viewfinder, I can't tell if it flashed again. There's another flash. There's another flash. Let's go down to 200 volts. And it'll take time because I'm charging a 0.5 microfarad. There's a flash. Let's go down to 125 volts. It's just going to take a much longer time to charge that capacitor that's inside the C2 unit. But eventually, even at the 125 volt level, it's going to flash. And it might take a minute or two. But essentially, this is almost capable of, well, if I went to double this is 3.25 gig ohms, I would bet I could find a 6 gig ohm leakage with this. But I would want to use my unit in series with it because of the smaller capacitor value in here. It's going to be much faster to respond. So we're going to take their leads on, or these leads out. I am going to plug this back into the C2. If you're really serious about finding leakage in those mica capacitors, and I'm going to, and you might be saying, well, it takes a while for the flashing to start, but if you watch Mr. Carlson's unit, it takes quite a while for his unit to respond as well because he's using such a low voltage. Now, there, blinking, it's blinking already, and that's 3.25 gig ohms, and I hope the camera's showing that. Let's turn some lights out here. And this one, whoops, wrong plug, there we go. What did I disturb in the process here? Yeah, I better shut that off before I get bit. Oh, I was shorting it halfway through the string too. Okay. Oh, that's why it stopped blinking. Excuse me while I plug the condenser tester back in. Okay. Everything's back in and turned on, and I'm sure you can pretty clearly see, because I can see it in the viewfinder now, the blinking that is occurring here on this NE51 lamp. And that's showing definite leakage. Now this is again 3.25 gig ohms. Anything, you know, if you're leaking greater than that, it probably isn't a problem, but it will find it. And if I had enough resistors and enough room on the bench, I mean, from this flash rate, it's obvious I could double that resistance. I could get up to 6 gig ohms. And that's at 125 volts. Okay, relatively safe. Now, I will actually grab, okay, I'm holding the test leads, and you can see the lights on steady now. I'm shorting them with my hands. I can't even feel that. In fact, you can see the Heathkit blinking away over there, now that I'm using my hand as a leakage source. And I'm confident enough in this that I will use both hands, which is deadly dangerous to do, but this is across both hands. You should never do this. Don't do this. I'm an expert. I've been doing this for years. I know what I can safely touch. But there's there's leakage across my body, and you can see it's very clearly showing. So, what's the end result here? For about $3 in parts. Oh, even the Heathkit's blinking now. Their cap has been charged. If I turn this up, let's see what happens. My flash rate here is going to increase. That should eventually charge as well. It'll eventually charge that cap. There it is, blink. You want a really sensitive leakage tester? Buy one of these instead of one of the newer ones. The C2 is going to be far more sensitive to leakage because of this circuit. You could actually take this apart and change that 0.5 microfarad that's in here. The 0.5 microfarad that's right here across the NE2 lamp. If you change that to a 0.02 like I have in here, you'll have the increased flash rate, and it'll be far more sensitive to small leakages. However, as you can see from the blink, and I'm not even sure if that's going to show up with the lights. I can't tell in the viewfinder if you can see that blinking or not. But if I turn the lights back off, I know you can. And let's see, look in the viewfinder. Yep, I can see it in the viewfinder. You just have to put up with it being a little dimmer. Is it as elegant as Mr. Carlson's? Absolutely not. Is it as safe as Mr. Carlson's? Absolutely not. We're still playing with high voltage. However, if you're comfortable working around high voltage and you have one of these capacitor testers in your possession already, and you've been using it and you're comfortable using it, this little additional circuit right here will ensure that you find the tiniest leak in whatever capacitor, whether it's a silver mica, a molded mica, paper, whatever you have. This will likely find it, because when this lamp is off, its impedance is nearly infinite. As long as you have a good quality capacitor in parallel with it that doesn't leak off the voltage and will charge up from the leakage, discharge to the lamp, you'll get an indication. I hope I made that clear. Sometimes I don't use the best phraseology, if you will. But this is extremely sensitive to leakage and will indicate, I think I would put this up against his predictive unit. Again, I'm running at 125 volts versus his 27. His is nice. His is a nice little piece of gear. It adds a nice level of safety to your lab. But it's complex. You're going to have to scrounge up a bunch of parts and put the thing together. And this is probably stuff you have in your junk box already. 10 or 15 minutes work. You can have an extremely sensitive leak tester to use with your C3, or change the capacitor in your C2 to a 0.02 so the charge rate is faster. And again, you can see how much dimmer that blink is compared to, well, I'm just going to make it flash quickly, because if, let's see, okay, I'm on the 120 volt range. You can see how bright that flash is over here compared to this. Now this one's on steady because, or appears to be on steady. What it is the flash rate is now just so high it appears to be on steady because I'm using my fingers for leakage. There's a little bit less. I'm using a drier part of my hand. You can see the flash rate slowed down. If I squeeze them tight, it appears to be a constant steady light, but it actually isn't. It's just flashing faster. Not as bright as this one. This one has the 0.5. This has the 0.02. But the 0.02 will let you much more quickly, where you might have to wait 2 or 3 minutes for this to do a single flash. This will do it every few seconds. And you might miss it with that because you didn't want to wait 5 minutes for that light to flash. This will tell you immediately you have a leak. And while we're at it here, I know that somebody somewhere is going to say, you didn't prove that it stops blinking on a good capacitor. How do we know that it just doesn't blink on everything and show everything being leaky? So we'll go back over here and plug this thing in, being careful to observe polarity. And the reason it's not for the cap I'm worried about. This is the ground side. And because my little project box happens to be aluminum, I want to make sure that that's cold. It's not hot. Otherwise I could touch here and here and get a serious belt. Here we have some Sprague orange drops. And just a random grouping that I grabbed out of my drawers of capacitors here. And let's see, the voltage rating on this is 200. So we'll hook this guy up. And you're going to see on these units a single blink when you first hook it up. Let me discharge this now because I just hooked it up. You're going to, of course, see a blink when it first goes into test because the capacitor has the charge. There you go. It went on and off. So now that capacitor is charged and current flow should stop, which means the capacitor in here or in here will not charge again. Now if I turn the voltage up, you'll see another blink. There you go. Because we're charging the whole system, but current should stop flowing through this, and once the current stops flowing through the non-leaky capacitor, this one should stop blinking. And we'll see what happens. Okay, nothing. Now if I touched, that's charged. There we go. You can see we've got the circuits working. Now the downside to this is it does not discharge the capacitors. That would add some complexity. It could be done. Let's test another one, another orange drop. And again, what's the voltage on this one? This is an 800 volt cap, so I can run this thing all the way up to 500 volts without a worry. And you probably saw, you can see it's blinking as it's dropping the voltage because it's discharging, and it blinks a couple times as you turn the voltage up, but that should be the end of the blinking. Oh, there was another blink. It might have still been charging slightly. And that's it. No more blinks. That cap is fully charged, and that's it. No more blinks. No leakage. Pretty healthy snap off of that when I discharge it. What do we got here? We have, again, 600 volts. So we're going to get a pretty good flash as it charges, because I didn't even turn the voltage down. We might get one more blink as everything settles out. Nope, doesn't look like it's going to blink again. Oh, it did. That might have been just me. But that should pretty much be the end of it. So, I would call those caps good. Of course, being Sprague orange drops, I would expect them to be good. You can tell. That would hurt. That is a 0.1 microfarad. I don't know what that is. It's not marked. It's got a code on it. I'm going to have to measure that before I put it. No, 683. 0.6 microfarad. And this one's a 0.5 microfarad. This is what's inside the unit for the circuit as it comes from Heathkit. And if we charge that puppy up, that's going to have a pretty good snap. That would hurt you. And this is only 0.5 microfarad. You do this with a 4, 5, 6 microfarad capacitor and get your hands across it, it can stop your heart, because the discharge, not only the voltage, but the capacitor can supply a lot of current, so be careful. Okay, I hope that some of that made sense. I hope I wasn't too disjointed. It's been a while since I've done a video, and just kind of tossing this together. Just something I thought I'd do this afternoon. I'm the Radio Mechanic. Hope somebody out there found this useful. Take care. See you again.